So now we're going to talk about functions and relations. Okay? A relation is anything that relates two or more sets of things together. Sounds really vague and broad, right? Well, in its general sense, a relation is really broad. So for example, I could define the relation R as follows. Red triangle, blue circle, green square. Okay. So this is a relation which I've named big R, and it's relating two things together. The things in the first ordered pair, the first position of the ordered pair, in this case colors, red, blue, green, the things in the second position in the ordered pair, in this case these shapes, triangle, triangle, circle, square. So it's saying red relates to triangle, blue relates to circle, green relates to square. Okay? So it's just relating these two groups of things together, colors and shapes, and it's doing so in this way. Now often when we're dealing with a relation and later a function, we want to be able to talk about items in the first set. So in this case, items in the first position, red, blue, and green. And we call those things the elements of the domain. So at its most basic, domain are elements or things in the first set of a relation. So in this case, our domain would be red, blue, and green. So our domain would consist of the elements red, blue, and green. Now in this case, our domain is what's known as discrete, meaning it's just a list of things. There's only three things in the domain of R, red, blue, and green. So I use a discrete list with curly brackets to list them, red, blue, and green. So domain is things in the first set. Well, we also want to be able to talk about things in the second set. Things in the second set are known as our range. So range is elements or things in the second set. In this case, that would consist again of just three things, triangle, circle, and square. The relation R relates things from this group to things in this group, okay? So that's an introduction to relations as well as domain and range. Now, oftentimes in math, we're not going to be relating things like colors and shapes. We're going to be relating numbers, right? And we're going to relate those through a relation or a function. All right, so let's look at another example. I'm going to pause and put another example up here. Then we're going to see if we can't think about what things are in our domain, what things are in our range, and then we're going to talk about what's the difference between a function and a relation. Okay, so here's another relation. I've named this one S. I've kept R up here so we can continue to talk about it. The relation S consists of 1, 2, 3, 4, 5, 6 ordered pairs. Each ordered pair relates two things together. We've got Juliet and Romeo, Cleopatra and Antony, Rachel and Ross, Scarlett and Rhett, Rachel and Joey, Penny and Leonard. Okay? So just as a reminder, our domain is elements in the first set. So in this case, our domain would consist of Juliet, Cleopatra, Rachel, Scarlett, Rachel, and Penny. Our range is the elements in the second set. So in this case, our range would be Romeo, Antony, Ross, Rhett, Joey, and Leonard. Okay. So domain and range, a relation relates those two things together. Okay. Now, what I want to talk about next is I want to talk about what makes some relations function. So a function is a special type of relation in which, so a function is a special type of relation in which each element of the domain can only be paired with one element of the range. Okay, so I've written that here. A function is a special type of relation in which each domain element is paired with a unique range element. In other words, every domain can only be mapped to one unique range element. A nice way of thinking of this is to say that domains can't do double duty, okay? So up here, one of these would qualify as a function and one of them would not. Let's think about which one would be a function and which would not. Now remember, a function has this property that each domain is mapped with a unique range. In other words, a domain can't do double duty. So if we look at R, we have red mapping to triangle, blue mapping to circle, green mapping to square. Each domain element, red, blue, and green, is not mapping to anything except for something unique. That was really convoluted. Each domain is paired with a unique range element. In other words, no domain is repeating and paired with something else. I don't have a red triangle and a red star. The only thing that's red is going to be my triangle. So this is a function. Yay! Okay. Unfortunately, that means S is not a function. Why does S fail to be a function? Well, S fails to be a function because if we look at this ordered pair and this ordered pair, we have one domain element, Rachel, who's doing double duty, right? Rachel is mapping to Ross, but Rachel is also mapping to Joey. That means the relation S is not a function. Okay? So again, a function is just a special type of relation where each domain element is paired with a unique range element. In other words, no domain element can be double duty.